Okay, so do a video around the TBS, one of our temperature sensors from SICK, and how it kind of marries with the PLC via IO link. A lot of IO link sensors spit out just the raw data, say a distance sensor or something like that. Every now and then we run into some that you have to scale similar to analog. The sensor I've got here is a 6065579. I have a temperature range of -20°C to +80°C. This is key to know because this is numbers we'll need to have to scale. So if you come to downloads and you come to the manual, which is here, I already have this pulled up. So if you read this little note right here, so we have to know the range of the sensor when it comes over IO-Link is going to give you from 0 to 10,000, whereas 1,000 is going to be the lower range and 9,000 will be the higher. So since I have a sensor that is -20 to +80 degrees, so -20 will correlate with 1,000, where +80 will be scaled to 9,000. It says in the manual here. It also says something here about the 14 bits to temperature value, because of IO-Link it uses 2 bytes or a word for Q1 and Q2. So if you need to find the IODD file, you can come to downloads here and then software, and then you can grab the IODD file. I've already pulled the IODD file out here, so you can see exactly what it was saying. It comes out of a 14-bit integer. So I've already got this set up in my PLC program, and I'll just kind of show you how I did this. First, I brung the data in over IO-Link. I brung those 2 bytes in. Then I did a byte swap. So 16,003 for 2 bytes, and then I byte swap those, and then I use this XVer to transfer bits so that I could break out those 14 bits that I have here. So 14 bits, destination starting at 0, on my source word starting at 2. So on bit 2, I pulled 14 bits out and put it in destination word 2D8872. And that's where my data is at. So if I come here and I come to binary, you can see right now I'm at 4,458. So that's that scaled value that we were talking about from 0 to 10,000. But where we're going to put our lower and upper limits is going to be 1,000 will be equal to the lower limit, which is -20 on this sensor. The upper limit will be 9,000, which is 80 degrees positive. So what I did here is I come in and I've got my scaling instruction, and then these are just the source words, the control for the scaling function. So since I didn't want to put a negative in here, I just said 0 instead of it being if I had -20. If you look here, you see I can put it back in decimal. If I would have put -20 in here, then I just would have put 1,000 here. But since I went with 0, that's 20%, and 20% of 8,000 is 16,000. So 16,000 plus 1,000 is equal to 2,600. And then my max is 800 or 80 degrees Celsius. So I just put a 0 in there where I can get the extra decimal point. And then down here, that's that 9,000. So 80 and 9,000. So that's the max of the scale. And since I didn't want to put -20 in there, I just did 20%, which is 0 times that. And then now you can see if I come here and I go back to hexadecimal. So I've got the sensor here, and we can look at the scaled value here. So if I start to warm the sensor up, we should see that those 2 values are the same. Anyway, that's how you take the TBS from SICK, bring it over IO-Link, and scale the data and get an actual temperature value.